Hello, welcome to my channel Nightlight Science Stories. Today, we leave the familiar world behind and travel to the ends of the Earth, Antarctica. It is a continent of silence, covered by an ice sheet that averages 2 kilometers in thickness. To the naked eye, it looks like a frozen wasteland, a white desert where time stands still. But appearances are deceiving. Beneath this massive frozen blanket lies a hidden world. Scientists have discovered that Antarctica is not just a block of ice sitting on rock. It is a dynamic, shifting environment hiding over 400 subglacial lakes, rivers, and even active volcanoes. This hidden continent has been sealed off from the rest of the planet for millions of years. Today, we are going to drill down to the layers of history to uncover the secrets waiting in the dark. The ice itself is a time machine. As snow falls year after year, it gets compressed into ice, trapping tiny bubbles of ancient air. By drilling ice cores that are kilometers long, scientists can read the Earth's history like a book. These air bubbles contain samples of the atmosphere from 800,000 years ago, revealing how carbon dioxide levels and temperatures have fluctuated over eons. Each layer of ice tells a story of volcanic eruptions, solar storms, and the rise and fall of global temperatures. It is the most precise climate record we have. Standing on the surface, you are standing on top of archived history. But as we go deeper, the pressure increases and the ice begins to behave differently. It flows like slow-motion honey, moving towards the coastlines, reshaping the continent from within. The biggest secret lies 4,000 meters beneath the surface, Lake Vostok. It is one of the largest lakes in the world, similar in size to Lake Ontario, yet it hasn't seen sunlight for at least 15 million years. The immense weight of the ice sheet above creates enough pressure to lower the freezing point of water, keeping it liquid despite the sub-zero temperatures. It is a sealed ecosystem. For decades, this lake was a ghost, detected only by radar and seismic surveys. The water here is pristine, isolated from biological contamination and the modern atmosphere. It is an alien world right here on Earth. The conditions in Lake Vostok are thought to be similar to those on Jupiter's moon Europa or Saturn's Enceladus, making it the perfect practice ground for the search for extraterrestrial life. Can life exist in such a hostile place? Cold, dark, and under crushing pressure? The answer is yes. Scientists have found microbes in the accretion ice just above the lake's surface. These are extremophiles, organisms that thrive where nothing else can. They don't need sunlight. They feed on minerals and chemical reactions in the water. They have been evolving in isolation for millions of years. These microbes are living fossils, descendants of surface bacteria that got trapped when the continent froze over. They have adapted to survive by slowing down their metabolism to a near halt. Their existence proves that life is incredibly resilient. If life can hold on here, great under kilometers of ice, it reshapes our understanding of where we might find life in the frozen corners of the universe. One of the strangest visible clues to this hidden world is blood falls. In the McMurdo Dry Valleys, a bright red waterfall pours out of the Taylor Glacier. For a long time, explorers thought it was red algae. But we now know the truth is geological. The water comes from an ancient subglacial saltwater lake trapped beneath the glacier for over 1 million years. The water is incredibly salty and rich in iron. When it finally reaches the surface and contacts the oxygen in the air, the iron instantly rusts, turning the water blood red. It is a dramatic visual reminder of the chemical activity happening out of sight. Inside this subglacial brine, bacteria are living by breathing iron and sulfur instead of oxygen, a completely unique metabolic pathway. But lakes aren't the only thing hiding down there. Deep beneath the East Antarctic ice sheet lies an entire mountain range called the Gamburtsev Mountains. These ghost mountains are the size of the European Alps with peaks rising to 3,000 meters, yet they are completely buried. No human has ever laid eyes on them. We only know them through gravity and radar sensors. How did such massive mountains form in the middle of a stable continent? It remains a geological puzzle. Usually, mountains are formed by colliding tectonic plates, but the Gamburtsovs are ancient. The ice has actually protected them from erosion, preserving their jagged peaks for millions of years. If the ice were to melt, a landscape sharper and more dramatic than the Alps would be revealed. Antarctica is also the world's best collector of space rocks. Meteorites that fall here are preserved in the deep freeze. As the ice flows and hits mountain ranges, it pushes these dark rocks to the surface. Against the white snow, they are easy to spot. More meteorites have been found in Antarctica than anywhere else on Earth combined. These rocks are messengers from the early solar system. Some have come from the Moon, and some even from Mars, blasted off by ancient impacts. Inside these Martian meteorites, scientists look for microscopic signs of past life. The ice of Antarctica is essentially a catcher's myth for cosmic history, storing samples from across the galaxy for us to find and study. However, the ice is not permanent. We must talk about the Doomsday Glacier, the Thwaites Glacier in West Antarctica. It is the size of Great Britain, and it is melting. Warm ocean water is eating away at it from underneath, destabilizing the shelf that holds it back. Its collapse could raise global sea levels by over half a meter, triggering a chain reaction. This is where the hidden world becomes a threat to our world. The physics of how ice fractures and slides into the sea is complex. Scientists are deploying robot submarines beneath the ice shelf to measure the melting rates. It is a race to understand the stability of this frozen giant before it wakes up. The silence of Antarctica is being broken by the cracking of ice. It wasn't always like this. If we go back 90 million years, Antarctica was a lush green rainforest. We have found fossilized roots, pollen, and even the remains of dinosaurs. The continent was warm, teeming with life, situated further north than it is today. It is hard to imagine palm trees swaying where there is now only a blizzard. This tells us that the Earth's climate is capable of radical shifts. The transition from a greenhouse Earth to an icehouse Earth happened because of changing CO2 levels and the opening of ocean passages that isolated the continent. Studying this past helps us predict our future. If we continue to warm the planet, we might be pushing the Earth back towards a state where the ice sheets cannot exist. To truly explore the subglacial lakes without contaminating them, engineers are designing cryobots. These are long, slender probes that melt their way through kilometers of ice using heat. They carry sterile labs inside them. Once they reach the water, they will release mini-subs to hunt for life. It is the ultimate engineering challenge, drilling without destroying. These missions are in the planning stages now. The goal is to retrieve a sample of water from Lake Vostok or Lake Ellsworth that has absolutely no contact with the surface world. The moment we bring that sample up, we might be looking at biology that has taken a completely different path from the rest of the planet. It is the final frontier of biology on Earth. If you put your ear to the ice, you would realize that Antarctica is not silent. It is singing. The Ross Ice Shelf, a floating slab of ice the size of France, constantly vibrates due to wind and ocean waves. Sensors embedded in the ice have recorded a constant low-frequency hum. It creates a mournful, eerie melody that changes pitch depending on the temperature and the integrity of the ice surface. This song is actually a distress signal. When the pitch changes, it indicates that the ice is melting or developing internal fractures. Scientists use these acoustic signatures to monitor the shelf's health remotely. It feels like the continent itself is a living organism, growing under the stress of a warming climate, communicating its physical state through vibrations that travel for hundreds of kilometers. The silence is also broken by icequakes. Unlike earthquakes caused by tectonic plates, these are caused by the sudden shifting of glaciers. As a glacier moves over rock, it sticks and then slips, releasing massive amounts of energy. These quakes can be as powerful as a magnitude 5 earthquake, shaking the ground and sending cracks shooting through the ice at the speed of sound. Listening to an icequake is terrifying. It sounds like a gunshot or a cannon blast echoing across the frozen plains. For researchers living in tents or stations, it is a constant reminder that the ground beneath them is moving. These seismic events allow us to map the friction at the base of the glacier, helping us predict how fast the ice will slide into the ocean in the future. Now let's dive beneath the Ross Ice Shelf. Here, the ocean is covered by a roof of ice hundreds of meters thick. It creates a vast twilight world that extends for hundreds of kilometers from the open sea. For a long time, we thought this area was a barren desert. How could anything survive so far from the sunlight that powers the food chain? We were wrong. When we drilled holes and lowered cameras, we found a surprising ecosystem. Upside-down anemones and strange fish swim upside down, using the ice ceiling as their floor. They feed on organic matter carried in by currents from the open ocean. It is a slow, dark world where life hangs in suspension, defying our expectations of where biology can take hold. In these frozen waters, we witness a deadly phenomenon, the brinacle, or the ice finger of death. When sea ice forms on the surface, it expels salt, creating a super salty, super cold brine that sinks rapidly because it is denser than seawater. As this brine sinks, it freezes the fresher water around it, forming a hollow tube of ice that grows downwards like a stalactite. When this icy finger hits the ocean floor, the result is catastrophic. It creates a river of ice that spreads instantly across the bottom. Any slow-moving creature, starfish, urchins, crabs, that gets touched by this web is instantly frozen to death, encased in a tomb of ice. It is a brutal silent killer, a visible manifestation of the extreme physics governing the polar oceans. Antarctica is also a land of fire. Mount Erebus is the southernmost active volcano on Earth. It holds a permanent lava lake, one of only a few in the world. Seeing bubbling magma surrounded by miles of ice is a surreal contradiction. The heat from the volcano melts the snow above it, creating a network of intricate ice caves around the summit. Inside these caves, the temperature can reach a comfortable 25 degrees Celsius, 77 degrees Fahrenheit. They are humid and warm, protected from the blizzard outside. Scientists believe these fumarolic ice caves could host unique microbial life forms that have adapted to this island of heat. It is another potential habitat for life, a thermal oasis in a frozen desert. The volcano emits steam that freezes instantly upon hitting the air, building massive ice towers or fumaroles that can stand 20 meters tall. They look like chimneys from a Dr. Seuss book, puffing out white smoke against the deep blue sky. These towers are fragile and constantly changing, shaped by the heat from below and the wind from above. Walking among them feels like exploring another planet. And in a way, we are. NASA studies Mount Erebus to understand volcanoes on icy moons. If a volcano can stay active under the Antarctic ice sheet, could similar geothermal heat be keeping the subsurface oceans of Europa liquid? The connection between fire and ice here is a key to understanding planetary habitability. Not all of Antarctica is covered in ice. Welcome to the McMurdo Dry Valleys. This is the driest place on Earth, having seen no rain for nearly 2 million years. The katabatic winds here screen down from the mountains at 320 kilometers per hour, evaporating all moisture. It looks like the surface of Mars' red rock, dust, and absolute desolation. Here, we find mummified seals that wandered inland centuries ago and died. Because there is no moisture and no bacteria to decompose them, their bodies are perfectly preserved for thousands of years, They are eerie statues in a silent landscape. The dry valleys are so similar to Mars that Viking Mars landers were tested here in the 1970s. In the middle of the dry valleys lies Don Juan Pond. It is only ankle deep, but it is the saltiest body of water on Earth, saltier than the Dead Sea. The water is so full of calcium chloride that it remains liquid even at -50 degrees Celsius. It never freezes. It is a chemical sludge rather than a lake, a testament to the extremes of chemistry. Looking at this pond gives us hope for finding liquid water on Mars. We know Mars has salty brines. If water can stay liquid here in the coldest, driest place on Earth, it could flow on the red planet too. Don Juan Pond is a natural laboratory showing us the absolute limits of where water, the elixir of life, can exist. Digging into the rock of the Transantarctic Mountains, paleontologists have found the Cryolophosaurus, or frozen crested lizard. This dinosaur lived here when the continent was warmer. Finding its bones requires jackhammers and rock saws to cut through the permafrost. It is the toughest paleontology in the world. These fossils prove that Antarctica was once a migration bridge connecting Australia and South America. Animals walked across this landmass before it broke apart. The frozen continent holds the missing pieces of the puzzle of how life spread across the southern hemisphere. Every summer season, scientists race against the weather to uncover these ancient secrets. Before we leave the geology, let's look at one more biological oddity caused by the physics of the water: giant sea spiders. In most of the world, sea spiders are tiny. In Antarctica, they grow to the size of dinner plates. This is polar gigantism. The freezing water holds much more oxygen and warm water. Because these creatures breathe through their skin, they have no lungs. The oxygen-rich water allows them to grow larger without suffocating. They move slowly on long, spindly legs, probing for soft corals to eat. They are a perfect example of how the environment dictates the shape of life. In the oxygen-soaked deep, the rules of size are rewritten. Antarctica is not just an isolated block of ice at the bottom of the world. It is the engine that drives the global ocean conveyor belt. As sea ice forms around the continent in winter, the salt is expelled, creating extremely cold, dense, and salty water. This is known as Antarctic bottom water, the densest water mass in the world oceans. This heavy water sinks rapidly to the abyssal plains, pushing the deep water northwards into the Atlantic, Indian, and Pacific basins. This sinking action pulls warmer surface water south to replace it. This massive, slow-motion circulation regulates the entire planet's climate, distributing heat and nutrients globally. If this engine were to stop, the world's climate would change drastically within decades. Encircling the continent is the Southern Ocean, home to the Antarctic Circumpolar Current, ACC. This is the only current that flows completely around the globe without hitting a continent. Driven by the fierce westerly winds known as the Roaring 40s and Furious 50s, it transports more water than all the world's rivers combined, acting as a barrier that keeps warm tropical waters away from the ice. Crossing this current, especially through the infamous Drake Passage, is a rite of passage for anyone traveling to Antarctica by sea. Waves can reach 15 meters in height, tossing even large research vessels like toys. It is the roughest stretch of ocean on Earth, a violent moat protecting the frozen kingdom. Humans do live on this frozen continent, but only temporarily. There are over 70 research stations run by nearly 30 nations. The most isolated is the Amundsen Scott South Pole Station, sitting directly on the geographic South Pole. During the summer, it is a bustling town of 150 scientists and support staff. The sun never sets, circling the horizon 24 hours a day. It is a place of extreme science, neutrino detectors buried deep in the ice, telescopes observing the cosmic microwave background, and atmospheric sampling. But it is also a place of human endurance. The air is thin, equivalent to 3,000 meters altitude, and dry, and the temperatures even in summer rarely rise above -20 degrees Celsius. But then comes winter. From mid-February to late October, the station is completely cut off. The sun sets in March and doesn't rise again for 6 months. The temperature drops below -70 degrees Celsius, -94 degrees Fahrenheit, cold enough to freeze jet fuel. No planes can land. No ships can reach the coast. A skeleton crew of about 40 people, the winterovers, are left alone in the dark. This is the ultimate test of psychology. Confined to the station, they become a family and a tribe. They face polar T3 syndrome, a condition involving memory loss, mood swings, and a fugue-like state caused by the extreme isolation, darkness, and altered magnetic field. It is the closest simulation we have on Earth to a long-duration space mission to Mars. Resupplying these stations is a logistical nightmare. Icebreaker ships must smash their way through meters of thick sea ice to reach the coastal bases like McMurdo Station. The sound of the steel hull grinding against the ice is deafening. They carve a channel that supply ships can follow, delivering fuel, food, and equipment for the entire year. Everything must be brought in, and everything, including all human waste, must be taken out. Antarctica is protected by the Antarctic Treaty, which designates it as a natural reserve devoted to peace and science. The rule is leave no trace. It is a fragile balance of maintaining a high-tech human presence in the pristine environment. For inland stations, the lifeline is the LC-130 Hercules aircraft, equipped with massive skis instead of wheels. They land on groomed snow runways on the ice sheet. The pilots have to navigate whiteout conditions, where the sky and the ground merge into a featureless white void, destroying depth perception. Landing a 70-ton plane on ice requires immense skill. The ice runway itself is constantly moving and cracking. If a plane breaks down at the South Pole, it often has to stay there for the winter, buried in snow until mechanics can fly in the next summer to fix it. It is aviation on the edge. Science isn't just done on the surface. Divers plunge into the freezing waters under the sea ice. They wear thick, dry suits, but their lips remain exposed to the -2 degrees Celsius water, going numb instantly. The visibility is astonishing, sometimes over 200 meters, because there is no sediment runoff from the frozen land. It is a world of silent beauty. They swim past colossal ice stalactites, giant sponges, and curious weto seals whose calls sound like alien synthesizers. But it is dangerous. If they lose the guideline back to the single entry hole, they will never find their way out before their air runs out. The ice ceiling is a solid trap. The true locals are perfectly adapted. The Weddell seal can dive to 600 meters and hold its breath for over an hour. It has a layer of blubber nearly 10 centimeters thick. To keep its breathing holes open in the winter, it uses its teeth to saw through the ice, which wears them down over time. It is a tough life. Their blood is rich in hemoglobin to store oxygen. When they dive, their heart rate drops significantly to conserve energy. They are masters of physiology. Observing them in their natural habitat, under the ice, shows how life finds a way to not just survive, but thrive in the cold. On the surface, the emperor penguin endures the worst winter on Earth. They breed during the darkest, coldest months. After the female lays her single egg, she leaves to feed in the ocean, leaving the male to incubate it. He balances the egg on his feet, covering it with a brood pouch for 2 months without eating. They huddle together in massive groups of thousands, rotating positions so that no single bird is left on the freezing outer edge for too long. It is a masterpiece of cooperative survival. The temperatures drop to -60 degrees Celsius and winds hit 200 kilometers per hour. Yet, in this frozen hell, new life is born. Antarctica is unique in human history. It is the only continent with no native human population, no government, and no military activity. It is governed by the Antarctic Treaty System, signed in 1959. This treaty suspends all territorial claims and dedicates the entire continent to peaceful scientific research. In a world often divided by conflict, Antarctica stands as a shining example of international cooperation. During the height of the Cold War, American and Soviet scientists worked side by side here. It is a place where science transcends politics, a neutral ground where humanity comes together to understand our common planet. To predict the future, we must read the past. Deep in the interior, scientists drill ice cores, cylinders of ice over 3 kilometers long. These cores are the Library of Alexandria for climate science. Every year, a new layer of snow falls, trapping dust, pollen, and tiny bubbles of atmospheric air. As the snow compresses into ice, these bubbles remain sealed, preserving a pristine sample of the Earth's ancient atmosphere. We have continuous records going back 800,000 years. By crushing the ice in a vacuum and analyzing the gas released, we can measure exactly how much carbon dioxide and methane was in the air when mammoths walked the Earth. It is the only direct evidence we have of the link between greenhouse gases and global temperature. The ice doesn't lie. It keeps a perfect score of the planet's breath. The data from these cores is alarming. For hundreds of thousands of years, CO2 levels naturally fluctuated between 180 and 280 parts per million, driven by the Earth's orbit. Today, we have spiked past 420 ppm, a vertical line on the graph that has no precedent in the ice record. We are conducting a massive chemical experiment on the atmosphere, pushing the climate system into uncharted territory. The last time CO2 levels were this high was during the Pliocene epoch, over 3 million years ago. Back then, there were beech trees growing at the South Pole, and global sea levels were 20 meters higher. The ice cores are warning us. If we maintain these levels, the ice sheets will eventually adjust to match the Pliocene climate, which means a radically different map of the world. This brings us back to the greatest immediate threat, the Thwaites Glacier. Often called the Doomsday Glacier, it acts as a cork in a bottle, holding back the massive West Antarctic ice sheet. The critical danger zone is the grounding line, the point where the glacier leaves the bedrock and begins to float. Warm ocean water is seeping under this line, melting the ice from below. As the grounding line retreats inland, the glacier becomes unstable. It sits in a bowl-shaped basin that gets deeper further inland. This geometry creates a marine ice cliff instability. Once it starts retreating past a certain point, physics takes over, and the collapse becomes self-sustaining and unscalpable, regardless of whether we stop emissions today. It is a tipping point we may have already crossed. If Thwaites collapses completely, it could raise sea levels by 65 centimeters directly, but its collapse would release the rest of the West Antarctic ice sheet, leading to a potential rise of over 3 meters. This would reshape every coastline on Earth. Cities like Miami, Shanghai, and Mumbai would be inundated. It is not a question of if, but how fast. This is why scientists are so obsessed with Antarctica. What happens here in the desolate south determines the fate of billions of people in the north. The sleeping giant is waking up. Satellite data shows that Antarctica is losing ice mass at an accelerating rate, pouring billions of tons of water into the ocean every year. The transfer of mass is so huge it actually affects the Earth's rotation. But rising water isn't the only threat emerging from the melt. As the permafrost and glaciers retreat, they are exposing soil and organic matter that has been frozen for millennia. This biological time capsule contains ancient bacteria and viruses that modern immune systems have never encountered. We are essentially opening a Pandora's box of prehistoric pathogens. Scientists have already revived a 30,000-year-old giant virus called Pithovirus sibiricum from the Siberian permafrost. It was still infectious to amoebas after being frozen for 30 centuries. While it doesn't infect humans, it proves that viruses can remain viable in ice for geological timescales. As the ice melts, what else might wake up? Smallpox? Anthrax? Or something completely unknown? Another ticking time bomb is methane. Vast amounts of organic matter, dead plants and animals are frozen in the permafrost. As it thaws, microbes begin to eat this material, releasing methane, a greenhouse gas 80 times more potent than CO2 in the short term. You can see this in Arctic lakes where methane bubbles get trapped in the ice. You can literally poke a hole and light the escaping gas on fire. This creates a terrifying feedback loop. The world gets warmer. The ice melts, methane is released, which makes the world even warmer, causing more ice to melt. It is a vicious cycle that nature runs on autopilot once triggered. Antarctica also has vast reservoirs of methane hydrates, frozen gas cages, trapped beneath its ice sheet, waiting for the pressure to release. We must also understand the albedo effect. Antarctica acts as the Earth's white shield. White ice reflects about 80% of the sun's energy back into space, keeping the planet cool. But as the ice melts, it reveals the dark blue ocean or brown rock beneath. These dark surfaces absorb heat instead of reflecting it. This loss of reflectivity accelerates warming. It is like wearing a black t-shirt on a hot summer day instead of a white one. The shrinking of the polar ice caps means the Earth is absorbing more solar energy, heating up the system faster. Preserving the white surface of Antarctica is not just about saving penguins. It is about maintaining the planet's thermal shielding. There is, however, some good news. Above Antarctica lies the ozone layer. In the 1980s, we discovered a massive hole in it caused by human-made chemicals called CFCs. This hole allowed dangerous UV radiation to hit the continent. But the world came together to sign the Montreal Protocol, banning these chemicals. Today, the ozone hole is slowly healing. It is expected to recover fully by 2066. This proves that planetary scale, environmental damage is reversible if humanity acts decisively and globally. Antarctica was the scene of our biggest environmental mistake, but also our greatest success. It stands as a beacon of hope that we can fix the climate crisis if we cooperate. Back under the ice, in the shallow lakes of the dry valleys, we find stromatolites, layered mats of cyanobacteria. These are modern versions of the very first life forms that appeared on Earth 3.5 billion years ago. They are responsible for the great oxidation event that made the atmosphere breathable for us. Studying them in Antarctica is like looking into the cradle of life. They build their structures layer by layer, trapping sediment. They survive being frozen in darkness for months, and then photosynthesize rapidly in the summer. They remind us that life is a geological force, capable of changing the entire chemistry of a planet given enough time. Recent radar mapping has revealed that there is not just static water down there, but a massive network of subglacial rivers connecting the lakes. Water flows rapidly under the ice sheet, lubricating the base and speeding up the ice flow towards the ocean. It is a hidden plumbing system that moves billions of tons of water. Understanding this hydrology is key to predicting sea level rise. If the water pressure increases, it can lift the glacier off the bedrock, causing it to slide faster. It is a complex, fluid dynamic system occurring entirely out of sight. We are only just beginning to map these rivers, realizing that the solid continent is actually incredibly fluid at its core. If you want to go to Mars, you come to Antarctica first. The McMurdo Dry Valleys are the closest terrestrial analog to the Red Planet. NASA uses this frozen desert to test rovers, drills, and life detection instruments before sending them into space. The extreme cold, aridity, and UV radiation create the perfect testing ground for hardware meant for alien worlds. This is where the Viking landers' biology experiments were calibrated. If a machine can find life here, hidden inside a rock or under a frozen brine pool, it has a chance of finding it on Mars. Antarctica is the stepping stone to the solar system. It is the place where we learn how to ask the right questions when searching for life beyond Earth. The ocean surrounding the continent holds its own alien life. Meet the icefish. It is the only vertebrate on Earth that has no red blood cells and no hemoglobin. Its blood is completely transparent, looking like water. Because the freezing southern ocean is so rich in oxygen, the oxygen simply dissolves directly into its blood plasma without needing a carrier protein. This adaptation allows its blood to flow more easily at sub-zero temperatures, saving energy. Its heart is unusually large and pumps huge volumes of this clear blood. Looking at an icefish is like looking at a ghost. You can see its white heart beating and its pale gills. It is a radical evolutionary solution to extreme cold that exists nowhere else. How do fish survive in water that is minus 1.8 degrees Celsius, below the freezing point of regular blood? The secret is in their veins. Antarctic fish have evolved antifreeze glycoproteins. These special molecules circulate in their blood and bind to tiny ice crystals the moment they start to form, stopping them from growing and turning the fish into an ice cube. This natural antifreeze is thousands of times more effective than the antifreeze in your car. It lowers the freezing point of their bodily fluids, just enough to keep them alive in the supercooled water. It is a brilliant biochemical hack. Scientists are studying these proteins to improve cryopreservation of human organs and to create frost-resistant crops. In the dark depths beneath the sea ice, we encounter giants. The Antarctic realm is home to massive jellyfish with bells up to 1 meter across and tentacles trailing for 10 meters. They drift silently in the cold current, apex predators of the plankton world. Their size is another example of polar gigantism, fueled by the oxygen-rich water. Encounters with these gelatinous giants are rare and ethereal. Divers describe them as pulsing, alien spaceships in the twilight. In the absence of many large fish predators, jellyfish have become a dominant force in the Antarctic deep-sea ecosystem. They are beautiful, fragile, and deadly to anything small enough to get caught in their stinging net. Even in the freezing Antarctic deep, there are hot spots. Deep-sea hydrothermal vents have been discovered here too, but they are different from elsewhere. Instead of black smokers, many are cooler white smokers or diffuse flows. Yet, they are swarming with life, including the famous Yeti crab, with its hairy claws covered in bacteria that it farms for food. These communities rely on chemosynthesis, drawing energy from the chemicals venting from the Earth's crust rather than the sun. Finding them in the Southern Ocean connects the Antarctic deep to the global network of subsurface life. It proves that wherever there is energy, chemical, or thermal life finds a way to exploit it, even at the bottom of the world. Exploring these environments is too dangerous for humans, so we send robots. Autonomous underwater vehicles, AUVs like Icefin, are pencil-shaped robots designed to travel for kilometers under floating ice shelves. They are equipped with sonar, cameras, and chemical sensors to map the hidden cavities where the ocean melts the ice. These robots are our eyes in the most inaccessible places on Earth. They have discovered that the ice is melting much faster than expected due to warm ocean currents channeling into deep troughs in the seabed. The data they bring back is crucial for refining our climate models. They are the brave little scouts of climate science, venturing into the jaws of the glacier. The ice isn't just for studying Earth. It is a telescope for the universe. At the South Pole stands the IceCube Neutrino Observatory. It is the world's weirdest telescope, looking down into the Earth instead of up. It consists of thousands of sensors buried 2.5 kilometers deep in the ultra-clear ice. It detects high-energy neutrinos, ghostly particles that travel across the universe from black holes and exploding stars. They pass through the entire Earth, but occasionally one hits an ice atom, creating a tiny flash of blue light that the sensors detect. The pure Antarctic ice is the perfect medium for this. We are using the planet's ice cap as a giant lens to watch the most violent events in the cosmos. Every summer, teams of scientists ride snowmobiles across the blue ice fields, hunting for meteorites. The katabatic winds blow away the snow, leaving the ancient ice exposed. Any dark rock sitting on top is almost certainly from space. They spot them with the naked eye, collecting them with sterile tongs to avoid contamination. It is a treasure hunt for cosmic debris. These rocks hold the secrets of how our solar system formed 4.6 billion years ago. Finding a piece of Vesta or Mars sitting on the ice sheet connects the geology of Earth to the geology of other worlds. It is a humbling reminder that our planet is just one rock among many, constantly exchanging material with the cosmos. But the greatest challenge of Antarctica is not physical. It is mental. The isolation is profound. For the few who overwinter, it is a test of the human spirit. The total darkness, the confinement, the lack of fresh food, and the separation from loved ones create a unique psychological pressure cooker. It forces a deep introspection. In the silence of the polar night, stripped of modern distractions, people are confronted with themselves. Some find a profound peace and clarity, a polar zen. Others struggle. It is a place that amplifies whatever is inside you. Studying how crews cope here helps NASA prepare astronauts for the 3-year mission to Mars. As we approach the end of our journey, we must remember that Antarctica is a political miracle. The Antarctic Treaty, signed in 1959 amid the Cold War, declared the entire continent a zone of peace and science. Military activity and mining are banned. It is the only continent where all nations have agreed to put aside their differences for the sake of knowledge. This treaty is set to be reviewed in 2048. As resources elsewhere become scarce, there will be pressure to open Antarctica to mining and oil drilling. The future of this pristine wilderness depends on our ability to uphold the spirit of cooperation. It is a test of our maturity as a species. Can we protect a place just because it is valuable in its natural state? The melting of the ice sheets is so critical that scientists are considering desperate measures: geoengineering. Some proposals involve building massive underwater walls or curtains in front of glaciers like Thwaites to block the warm ocean currents. Others suggest drilling holes to pump water out from beneath the ice to increase friction and slow the slide. These are colossal engineering projects, costing billions and taking decades. They sound like science fiction or acts of desperation. Critics argue that we are treating the symptoms rather than the cause, carbon emissions. But the fact that we are even discussing re-engineering a continent shows the severity of the crisis. We are reaching for the emergency brake. What happens if we fail? If the planet warms by 4 degrees, Antarctica could eventually turn green again. While this sounds lush, it would mean a catastrophe for human civilization. The water locked in this ice would raise global sea levels by nearly 60 meters. The map of the world would be unrecognizable. Most major cities would be underwater ruins. This green Antarctica has happened before, but it took millions of years. We are forcing this transition in just a few centuries. The speed of change is the killer. Nature cannot adapt fast enough, and neither can our infrastructure. The ice is the sleeping giant that holds the coastline of every continent in its frozen grip. Yet, amidst the doom and gloom, there is resilience. The animals of Antarctica are tough. Adelie penguins have been here for 45,000 years, surviving the last ice age by finding small refuges. Life here is stubborn, but we are pushing them to their limit. Cruel populations, the foundation of the food web, are shifting south as the water warms. Protecting the Southern Ocean is the most effective thing we can do. Establishing vast marine protected areas, MPAs, gives these ecosystems a fighting chance. It creates a safe haven where nature can adapt without the added pressure of industrial fishing. We have the power to draw a line in the water and say, "This place is safe." The future of Antarctica lies in the hands of the next generation. Young glaciologists, biologists, and engineers are deploying new technologies, drones, AI, and satellites to monitor the ice better than ever before. They are the guardians of the cryosphere. Their research is not just academic. It is vital intelligence for the survival of our civilization. We are seeing a shift in consciousness. Antarctica is no longer seen as a distant white void on the map, but as the beating heart of the global climate system. We realize that what happens in Antarctica doesn't stay in Antarctica. The weather in your backyard is directly linked to the stability of the West Antarctic ice sheet. Let's take a moment to simply appreciate the staggering beauty of this place. The blue of the ice is not a pigment. It is the color of time itself, created by the compression of snow over millennia absorbing red light. The sculptures carved by the wind and sea are more majestic than any human cathedral. It is a world of pure aesthetics. Losing this landscape would be a spiritual loss as well as a physical one. There is a silence here that exists nowhere else, a silence so deep you can hear your own heartbeat. It is a place that demands humility. Standing before a glacier that is miles high, you realize how small and temporary we are in the face of geological time. Above the ice, the sky puts on its own show. The aurora australis, the southern lights, dance across the polar night. These are charged particles from the sun interacting with Earth's magnetic field. At the poles, the shield is thinnest, allowing the cosmos to touch the atmosphere. It is a reminder that Earth is a spaceship traveling through a dynamic solar system. In the total darkness of winter, this light show is the only color the winter over crews see for months. It connects the frozen ground to the burning sun. It is a phenomenon of pure physics that feels like magic. Antarctica is the best seat in the house for the greatest light show on Earth. We have traveled far in this hour. We started on the wind-swept surface, drilled down through the time capsule ice cores, swam in the subglacial Lake Vostok, and touched the bottom of the Southern Ocean. We've met the ice finger of death, the bloodless icefish, and the ancient viruses waiting to wake up. We have seen that this continent is not dead. It is alive and dynamic. It moves, it cracks, it flows, and it sings. It hides mountains and rivers in its belly. It is a world within a world, a frozen planet hiding in plain sight at the bottom of our globe. The final lesson of the ice is connection. The water molecules frozen in the center of Antarctica might one day be rain falling on your roof. The carbon you emit today will eventually be trapped in the bubbles of future ice. We are in a constant exchange with this frozen land. It is not over there. It is right here, in our climate, our oceans, and our future. We have the technology and the knowledge to protect it. The question is, do we have the will? The Antarctic Treaty proved we can cooperate for peace. Now we must cooperate for survival. Saving the ice is ultimately about saving ourselves. As explorers, we leave only footprints and take only data, but we carry back a sense of wonder. If this documentary has sparked a curiosity in you, then the journey has been worth it. The more we understand this frozen frontier, the more we will value it. Knowledge is the first step towards preservation. Keep looking at the map. Keep asking questions about the white spots. There are still mysteries down there waiting to be solved. Perhaps you will be the one to discover the next secret of the ice. The age of exploration is not over. It has just gone deeper. Thank you for joining me on this expedition to the end of the world. If you felt the chill of the wind and the awe of the ice, please hit the like button and subscribe to Nightlight Science Stories. Share this video to help spread the story of Antarctica. Let me know in the comments, what was the most surprising thing you learned about the ice? Don't forget to watch our previous documentary on the Mariana Trench. From the deepest ocean to the thickest ice, we continue to explore the unknown. Sweet dreams and stay curious. Goodbye.